Hello guys, myself Rajesh. Today we have to discuss about the effect on temperature changes in the stiffness method. Consider the simple problem of stresses. In a pin jointed stress strain of a figure shown in the, it is given as a cooled. The cooled is, we consider it as a negative. But it is given as a heated or heat, that we consider it as a positive. So the cooled of 20 degrees Celsius, find the forces in all members assuming the given alpha and the elasticity value, E value. So this is the given stress. You have three members of and also given areas, and considering this is 45 and this is 30 degree. So in this temperature changes, we have different steps. In the first step, we have to considering the initial or the external forces. You have to first find out the external forces. In this stress, there will no external forces, so you have to, the external force member is becomes 0. So we considering the two members, that is the horizontal one and second that is vertical. So now the second step should be the initial strain matrix. The initial strain matrix, the delta value, delta naught value. So as the members are cooled, the member will get shortened. How the member will get shortened? We have to assume that if the member is cooled, the length of the member is shorter, and if the member is heated, we considering it is a longer one. So it is given as a cooled one, so we have to consider it as a shortened. So you have to find out the initial strain problems of a different members. They have the totally 3 members, so you have to consider each member for the initial strain. So first initial strain is equal to that alpha value, whatever the given alpha value, that here the given is 1.2 into 10 to the power of minus 5 per degree Celsius. So total that alpha delta naught is equal to alpha into T into the temperature and the length of the first member. So the length of the first member is given as 6 meter. So we considering 1.2 into 10 to the power of 5 into the temperature changes is given as a 20 degrees Celsius temperature changes, and the length of 6 meter is given. They considered in mm 6000. We get 1.2. So like that you have to calculate the initial strain matrix for all the members, like member 1, member 2 and member 3. This is the second step. The third step, we have to finding out the displacement transformation matrix. The displacement transformation matrix, we consider it as a beta value. So in this you have considering the first member, whatever we consider in the assumed the member, the horizontal member, best they have to consider that first. This is because of this member, or because of this pulling of this member, there is a deformation of the stresses or the deformation of the other members. So because of this member we have deformation like this. So whenever there is a deformation in the direction of the applied member, then we have to consider it as a negative. In the opposite direction of the member, we consider it as a positive. So the delta 1 should be, this is 45 degree, that this is 1, the delta 1 becomes, it is exactly perpendicular to this the horizontal member. So cos of the delta of 90 is 0. So when you consider it to the delta second member, that cos of the 30 in the opposite direction, so we consider it as a positive, so that is 0.6666. Delta 3 in the third member, it is direction of the assumed member, so it is negative, so it is 0.707. Consider same that as the vertical, same the member deformation like that. In the same direction we consider it as a negative, the opposite direction we consider it as a positive. So like that you get this answer. Next fourth steps we have to considering the, after finding, before that you have to finding all these members forces, you have to write the tabla, that is the matrix value by, that is beta matrix, that is we get this beta matrix from those values. So the next one is elemental stiffness matrix. In the elemental stiffness matrix, we know that when the stresses will come, will only the elemental stiffness matrix should be AE by L. So we have to do this AE by L value for all the members. This is only the one member. You have to do all the members. So Km1 means that is elemental stiffness matrix. We can represent it any manner. We can Km or we can whatever we take. So I am considering it as Km. So AE by L. So for this, so for first member, that is Km1 is equal to A1 into E, that area will changes and E becomes constant. So that area is equal to 6000 into 20 divided by. So based on this you get this answer. Same you have to do all the members, that is different length and area, but the E becomes constant. So finally we get the K matrix, that is K we got here. And the next step is structural stiffness matrix. In the structural stiffness matrix, we have to finding out this formula, that F is equal to F bar, it is F bar is equal to F into beta into K into delta naught. This F bar equals, that is F is 0 because the initial there is no external force in this, so it is 0. So next one we have to calculating the K and beta and delta value. We are calculated already delta and we calculated already beta matrix. We are only calculating the K matrix. The K matrix should be, the K matrix is equal to transpose of beta matrix into K into beta. So the transpose of the beta matrix into K into this, so multiply all these things, we get K matrix. Based on that you have to finding out F bar. Once you get the F bar, the next step is what? Displacement. But finding out displacement, the delta value that should be beta into U. That U, or we consider it is F matrix, because here only we considering that F, it can take that F. So once you find how to find it, you know that beta already, you have to finding out F matrix. That F matrix should be the K into U. Here we are going to finding out U matrix, because that U is the deformation or the displacement. So you have to finding U is equal to K inverse into F bar. This is the F bar whatever we finding out here. So that U is equal to K inverse into F bar. That is to substitute the matrix values and you get U1 and U2 value. Once you get this U, you have to substitute in the delta. Delta here to where there's is not been considered as a delta value. Delta value is equal to beta into U into F matrix. So actually this is not finally you find out delta value, that is displacement value. This is displacement. Now once you finding out displacement, you have to finding out final forces. The final forces, the member forces, you have to find it. So my final forces is P is equal to K into delta, whatever we finding here, the delta and the whatever we final before delta naught. So that K value we have put it and substitute all the values, we get P value. This whatever we finding the final P value, that should be a member forces which is applied on the each member of the stress by stiffness matrix method or the stiffness method.
Thank you guys for seeing this video, and please like, share, comment and do subscribe. Thank you.